In college algebra, we started 1.7 over inequalities and absolute value inequalities. We started very basic. We just want to graph these on a number line. First off, when you see this or this, we need to use a open circle, open dot, something like that. And when we see that symbol or this symbol, we'll use a solid dot. So, on example 1a, all I ask is you draw a line with a dash on it representing the number in question. I see a less than symbol. I don't see the or equal line, so I'm going to do an open circle. And that reads x is smaller than 3, so I shade left. And for anyone struggling with their symbols, that reads x is smaller than 3. I guess it should say less than, but I want to use language that we're all familiar with. For example 1b, draw a number line, make a dash for the 1. This time I see an or equal symbol, the line underneath, so I'm going to do a solid dot. And that reads x is bigger than or equal to 1. So that means I'm going to shade to the right because it's bigger than. For C, that's a compound inequality, so I'm going to do 2 dashes. I'm going to make an open circle. I'll make a solid dot and shade in between. X is bigger than -1, but less than or equal to 3. All right, now we have a different type of notation, same idea though. So if you see parentheses, we're going to do an open circle. If you see brackets, let's do a solid dot. All right, so let's make our number line. And I see a parenthesis above or right next to the -1, so open circle. And I see a bracket, so we're going to do a solid dot for 4. And the comma tells me any value in between is valid. I also want to write this as a compound inequality like that up there. So you write the first number, write an x, write the last number, and you write the symbols in between. Since it's a parenthesis, that means it's just less than, not or equal. And I see the bracket, so that means less than or equal. All right, let's draw another number line, a dash and a dash. I see brackets, so we're going to use a solid dot and shade in between. We need our inequality, so I'm going to write 2.5 is less than or equal to x, which is less than or equal to 4. On part C, most people get it right, but they write too much. So first off, we need a number line with 1 dash. I see a parenthesis, so open circle. And this goes to infinity, so that means shade forever to the right. And likewise, on the inequality, I just want to write, you can start with any number. I'm going to write -4, and x is bigger than it. Some people feel the need to write this. I won't count it wrong if you do that. technically you're supposed to write it like this. All right. All right, moving on. Number 3, now we have some actual linear inequalities because we have things to solve. I tell people to treat those less than and greater than signs just like an equal sign. There is one difference. If you divide by a negative, you must flip the inequality symbol. And that's going to happen on number 3 here. So we're going to treat it like an equal sign. No change at the beginning. I'm going to subtract a 3 from both sides. And then we divide by -2. This is a negative. Which means I need to flip the inequality sign. Let's say symbol. So now I have x is greater than -4. So I just flipped these two. All right. Draw your number line. Make a dash for -4. I don't see the or equal symbol, so I'm going to do an open circle. And that says x is bigger than -4. So shade to the right. Let's try another one. On number 4, we have more steps. I'm going to try and force it so that we don't have to flip the inequality, because you don't always have to. I'm going to move the x's to the right side. And that's going to give us a positive x. We won't have to flip the inequality. If you want to subtract 13x, you'll end up with a negative, and you'll have to flip the inequality. Let's move the 51 to the left side. And then final step, divide by 6. We're not dividing by a negative, so I leave that inequality alone. And we end up with -6 is bigger than or equal to x. Solid dot. That means x is smaller, so I shade to the left. All right, let's do a couple more. On number 5, we have a compound inequality to solve, and you're going to use the same concepts from Algebra 1. I want the x to be by itself, so I need to get rid of this and this. I don't really care what's on the other sides, but I need that 1 and that 2 to disappear. So just like with an equation, let's get rid of the 1 first, and I need to keep the whole thing in balanced. So I need to subtract a 1 from all sides. Kind of weird, but yet still makes sense with algebra, right? We want to keep the whole thing in balance. So now we have -4 and 2. Last step, I want to divide by 2. And then we're done. I didn't divide by a negative, so I didn't have to flip anything. If I did divide by a negative, I'd have to flip both symbols. Our graph looks something like this. All right, let's do one more together. For absolute values, you know, if I have an absolute value of a 4, I get a 4. If I have an absolute value of a -4, I still get a 4. That means for this 3 right here, the inside might be +3 or it might be -3. You have to account for both scenarios. All right? So first scenario, drop the bars and solve it as is. No changes, you just drop the bars. So that's assuming the inside was already positive. But what if the inside was negative to start with? You drop the bars, write a -3, and you flip the inequality. So you have to account for both scenarios. This up here, that was just an example. You don't have to have that. It's right. It's just not really related to this one. So you still solve it the same way. You add 4 to both sides. And then if you stop there, I'll still give you full credit, but I think it's important to realize, you know, x is smaller than 7, but look at the right one. X is bigger than 1. A better way to write this is in a compound inequality. I would love it if you would write it like that. That's the textbook way. And then put it in a number line and shade in between. Hopefully that makes sense. That was what we did on Friday. Bye, y'all.